Hello everyone, this is the video for this week's COMS 300 exercise, chi-square test. Because chi-square tests need a lot of math, so I think some of you are confused about it. So I made this video to show you how to solve the problem or how to conduct the chi-square test from step by step. So first, I will review how to calculate how to do a chi-square test. First, when you see the contingency table we discussed today, you have to state a null and alternative hypothesis. Then you will see what is the observed counts, and then you will calculate the expected count for each cell. Then, based on this observed count and expected count, you will calculate the chi-squared statistics. Then you will compare the chi-squared statistics with critical value level of significance 0.05. Then if the chi-square statistics is higher than the critical value 3.84, you will reject the null hypothesis. And if the chi-square statistics is lower than the critical value, you will not reject the null hypothesis. Then let's do the exercise again. So there is a contingency table, and there are 210 adults in the United States. So I draw a sample from the population, and there are 210 people in the sample. And they're male, female, and I ask, are you using Twitter? Do you have Twitter account or not? So according to the contingency table, 40 male have Twitter account, but 60 male do not have a Twitter account. However, 50 male have a Twitter account, but 60 male do not have a Twitter account. In total, there are 210 people. You will see this kind of contingency table, and based on this contingency table, you have to first state the null and the alternative hypothesis. You will calculate the expected counts for each cells and calculate chi-squared statistics, and then you will compare calculated statistics value with the critical value. And as I mentioned before, the critical value for alpha level 0.05 is 3.84. So you will compare the calculated chi-square statistics with the critical value 3.84. Then you will decide whether you will reject the null hypothesis or do not reject the null hypothesis. And this is the formula I discussed in class. And also you can see this kind of formula in the lecture slides. And you will have some time to do the practice. So first you have to state the null and the alternative hypothesis, calculate expected counts for each cell, calculate chi-square statistic, and you will compare calculated chi-square statistics with critical value, and you will make a decision. So I will give you some time. So please press the pause button for this video and do the practice. And then I will show how to solve the problem step by step. So let's do the practice. And okay, so I think all of you did a really good job at conducting this kinds of chi-square statistics. And I will show you a more detailed step-by-step process of how to conduct this chi-square statistic. First, you see, sorry. First, you saw the contingency table, and based on contingency table, you have to state what is the null hypothesis and what is the alternative hypothesis. And in this example, the null hypothesis is that male and female in the population are equally likely to have a Twitter account, which means that the probability that male have a Twitter account is same with the probability that female will have a Twitter account. However, the null hypothesis is that male and female in the population are not equally likely to have a Twitter account. So in this way, we have to first state a null hypothesis and alternative hypothesis. Then you will see what is the marginal total and grand total. So the blue box here, you can see the move of my mouse. The blue box is the marginal total for no Twitter account. And what is the marginal total for people with Twitter account? You can see the number 90. And the grand total in this example is 210. So in this way, you will find the marginal total and grand total in this contingency table. Then you will see the observed count in each cell. So observed count is a real number in the data you can see. So you can just take a table and you can easily find the observed count for each cells, like male with Twitter account, male with no Twitter account, female with Twitter account, female with no Twitter account. Then you will calculate the expected counts for each cell. So for expected count, you cannot see the numbers in the contingency table. You have to calculate it by multiply the column total by the row total divided by the total number. For example, as you can see here in the table, the expected count for male with Twitter account. You will calculate the expected frequency for male with Twitter account. How to calculate it? Then you will multiply the column total by row total. So you will multiply the marginal total for MSU and marginal total for Twitter account and divide it by the whole number. So you will calculate 100 times 90 divided by 210. Then you will do the same thing for each cell and you will easily calculate the expected count for each cell. I'm going to show you how to do that in the Microsoft Drawing. So now you see this kind of new table in the drawing. Then the black number 40, 60, 50, 60 is the observed count. Then you have to calculate the expected frequency. And I will calculate the expected frequency with blue number. So how to calculate the expected frequency for male with Twitter account? So calculated by marginal total for male times marginal total for Twitter and divided by the whole number. So 100, I'm going to show you again. So you will multiply this number by this number and divide it by this number. Is that easy to follow? I hope so. So you will calculate 100 times 90 divided by 210. And if you calculate it, you get the number of 42.86. This number is the expected count for male with Twitter. You can do the same thing for other cells. So let's calculate the expected frequency or expected counts for male with no Twitter account. You will multiply this number by this number and divide it by this number. So the expected frequency for male with no Twitter is 100 times 120 divided by 210. The number is 57.14. 50.714. I have to do that again. So 100 times 120 divided by 210 is 57.14. You will do the same thing for female with Twitter account expected frequency. Multiply this number by this number. So, and divide it by this number. So, $110 times 90 divided by 210. The number is 47.14. And also, expected frequency for female with no Twitter account is calculated by multiplying this number by this number divided by this number. So, $110 times 120 divided by 210. The number is, I already calculated, 62.86. So in this way, you calculate the observed frequency and expected frequency. The yellow box here, this one is the observed frequency. And the green, and this is a yellow one. And the green one and the blue one, this number you calculated, this number you calculated, this number is the expected frequency for each cell. Then, based on the observed counts and expected counts, you will follow the formula and you will calculate the number. So you will follow this formula: observed counts minus expected counts squared divided by expected counts. You will calculate this number for each cell. So I'm gonna show you how to calculate it. First, erase the numbers here. The black one is the observed counts, and blue one is the expected counts we already calculated. So we get the observed counts and expected counts for each cell. And just do the math following the formula. Let's go this side. The formula was like this. For each cell, observed count minus expected count squared and divided by like this, the count for each cell. So you will just follow the formula for each cell, just do the math. For cell one is male with tweeter. Male with tweeter. Just follow the formula. Observed frequency counts, observed counts minus expected counts. Squared it and divided by expected count. Then just put the numbers here. 40 minus expected count 42 is 6 with different color here. Squared it. Then divided by expected frequency. And if you calculate it, number is 2.86 times 2.86 divided by 42.86. Then the result is 0.19. That's easy, right? Do the math, but not that difficult to understand. I hope so. And you can do the same thing for other cells. CQ, the male with no tweeter. I want to calculate this cell. So same thing. So observed frequency for this cell male with no tweeter minus expected frequency, different number, different color, and squared it, 60 minus 7.14 divided by expected frequency. Then you will get the number of times 2.68 divided by 5714, and you will get the number of 0.14. Do the same thing for other cells. So female with tweeter. Count. I want to calculate this number from these cells. The frequency is 50. Frequency is this number. Observed counts. So we have to square that. Divided by 40 count. And you will get a number of 0.173. And C4 female with all tweeter account will get the number from this cell. So frequency minus expected count. Observed count with expected frequency. and divided by the frequency. And you will get the number here, do the math. And the number is 0.17. So in this way, we get the number for each cells by following the formula. Come do the math a little bit. So you will get this number, 0.19, this number, 0.14, this number, 0.17, this number, 0.13. Then, if you have to calculate this 4 number here, let's see this here, then you can get the chi-square statistics. So, there statistic is 0.19 plus 0.14 plus 0.17 plus 0.13. And if you do the math, I can get the number of 0.3. So 0.63 is the chi-square statistics you have to calculate it. Then, so I'm going to show you the process of how I calculate it. So we get the expected counts for each cell. We have to compare, we have to see the observed counts, blue colored one, expected counts, yellow colored one. And following this formula, we calculate the number for each cell, and then combine it, then we can get the chi-square statistic 0.63. Then we have to make a decision by comparing chi-square statistic with the critical value. So we calculated the chi-square statistic, and the value is 0.63, and the critical value at the significance level of 0.05 is 3.84. So we'll compare the number 0.67 chi-square statistics with the critical value 3.84. And because the chi-square statistics is lower than the critical value, you cannot reject the null hypothesis. And in the example, the null hypothesis is male and female in the population are equally likely to have a Twitter account. So we can say that we cannot reject the hypothesis that male and female in the population are equally likely to have a Twitter account. So that's the how to conduct the chi-square test and make a decision. This is all for this video. So I hope you feel more comfortable of how to conduct chi-square test. And as I mentioned in class, this week's piece covers statistics like independent t-tests, parity tests we learned last week, and also chi-square test, and a little bit thing about correlation. So this week you have to practice, review lecture slides, readings, and practice some statistics by your hands, then you feel more comfortable about taking quizzes. And if you have any question, please let me know, send me an email, and we'll meet in 2 weeks. So have a great day and see you in 2 weeks. Bye-bye.